For the Math 0306 Review Concepts worksheet, we're going to look at some concepts that you are kind of expected to know coming into Math 0306, but maybe could use a nice little refresher. And this does happen to be what the Section 1.1 homework in my math lab will be covering. So the first concept we're going to take a look at is that of distinguishing between an expression and an equation. Oh, and also it does say Section 2.1 here because the book was changed. It used to be 2.1, but it is indeed now 1.1 in your homework. So our first topic, looking at expressions and equations, determining which is which. The difference between an expression and an expression is any statement, mathematical statement, that has numbers that are by themselves, like this -9 here, we call that a constant, or variables that are by themselves. This variable a isn't here by itself, like this x is by itself. Any letters we call variables. And then sometimes, you have the letters and numbers attached. That's an expression. However, it doesn't make it an equation until we have an equal sign. So equation equals kind of the root word there, why we call it an equation, because of the equal sign. So this first couple examples here, which are expressions, which are equations, well, no equal sign. In this first expression, 8a minus 9. So that's an expression. Next example has an equal sign in it, so that's an equation. Next example after that also has an equal sign, that's an equation. Last example does not have an equal sign, that's simply just an expression. Negative 7m to the 6n over p to the third. That's just an expression involving numbers and variables. So, there's our first example, or first concept. The second question, though, still using those examples there, if any of the above equations are, or if any of the above are equations, are they linear? Why or why not? Well, in order to be linear, it means if you were to graph an equation, it would give you a line. But when you're just looking at an equation to determine if it's linear, it's going to be linear if it just has a single power of x, or a single power of whatever variable you're dealing with. So the only of the two equations we have, only this first equation here, the negative 3.5x equals x plus 4.1, that one is going to be linear. And as a reasoning why, all of the x terms are single powers of x. Whereas in this next equation you have your variable is to the second power. That makes that what we call a quadratic equation. Doesn't matter if there's fractions, doesn't matter that there's decimals, negatives, none of that matters. It's just because the single powers of x in this equation, that's going to make a linear situation. Whereas the second power of our variable here makes it what we call quadratic. We'll get more to that throughout the sections in this semester. So our next concept we're going to take a look at is solving equations. So solving equations anytime you solve any type of equation, whether it's a linear equation like we just looked at here, or if it's something that has a power, a higher power of your variable like this, the b squared, solving an equation is really just asking you what is the possible number value that we could plug in for this variable, that if we went through and kind of multiplied everything out, carried out all the operations, we get something on the left hand side here that equals whatever we'd get on the right hand side. So we're really looking for what number, if we plug in for b, 5 times that number squared minus 9 times that number is equal to 6 times whatever that number was. That's really what we're looking for. Now normally we have to solve an equation by ourselves, figure out, we have different methods to find out what value does b have to be. Other times they give you a value and ask you to check if it's a solution. That's a little bit easier. So we're doing that in our first example here. We're checking if 3 is a solution to that equation. So all we have to do is substitute the number 3 in for the variable b. Okay. So wherever we see the letter b, we're going to plug in the number 3. So rewriting our equation that we have here, 5b squared minus 9b equals 6b, we're instead going to have 5 times 3 squared. And I definitely encourage you to put, when you're plugging in, substituting a value in for a variable, put it in parentheses. Minus 9 times b, so 9 times 3, equals 6 times b, or 6 times 3. So this is what we're checking. We're trying to see, does that left-hand side equal the right-hand side? So that's why I put a question mark there. Go ahead and following out the operations. First we'd have to do exponents, so squaring that 3 we'd get 9. So here we have 5 times 9 minus 9 times 3. Does that equal 6 times 3? That's what we're going to check. We still don't know yet, so I'm going to put a question mark. Go ahead now, we can multiply. 5 times 9, 45. Minus 9 times 3, 27, equals 6 times 3 is 18. On my step, we're checking, is that actually going to be equal? 45 minus 18, or 45 minus 27 does indeed give us 18 on the left-hand side. So we're left with the statement 18 equals 18. Well, is that true? Yes, of course. So since we got a true statement, that means yes, 3 is a solution to that equation. Okay? 3 is a solution. If we ended up getting to the end here and we had some statement that wasn't true, like 17 equals 18, or 0 equals negative 5, something that didn't make sense, that wasn't true, then we would say 3 is not a solution. And that is all we have to do in that problem. The next example actually is going to require us to solve for x on our own, where they're not giving us a value to check for x like we just did. We have to use some sort of process, some sort of method to determine what is that specific value or values that x could be. This is a linear situation because these are all single powers of x in our problem, so there's only going to be one value that will work for x. Whereas up here, because we had a b squared, we had a second power of our variable, we would have had two values, two answers for b. But again, we're going to get to that later in the year. So to start a problem like number 4, we'd want to first combine any like terms on both sides, on the left hand and on the right hand side. So let's start with that. Combine like terms. We can clean this problem up a little bit. We have 4x minus x minus 5 and 4 plus 6x plus 3 on the right hand side. We can come through here on the left hand side. We can think of this as 4x minus a single x. Since they're both single x terms there, we can combine those. Those are like terms. So 4x minus the 1x is going to give us 3x. The minus 5 is not a like term, so we have to just bring down the minus 5. On the right hand side, we only have one x term, but we do have two constant terms, the 4 and the 3. So we can add those together, giving us 7. So on the right hand side, we're going to have 6x. Just bring the 6x down, plus the 7. So now that's a little bit nicer, a little bit easier to look at. And what we want to do now is we need to move our remaining like terms that are in the problem onto the same side. So we want to get our x terms together on the same side. We want to get our constant terms, the numbers without any variables, on the same side. And you can do it any way you want. as long as you get the x terms on one side, the numbers, the constants by themselves on the other. So I'm going to get the x terms on the right hand side. So in order to do this, I need to get rid of this 3x from this side. It's a positive 3x. To get rid of it, I want to subtract 3x. That will cancel it out. Whatever you do on one side, though, of the equation, remember to keep it balanced. We have to do to the other side of the equation. So subtracting a 3x here will cancel that out. And then on the other side of the equal sign, we have to subtract here. So take away 3x from the 6x. This gives us 3x remaining on the right-hand side as well. So bring down the minus 5 on the left-hand side. 6x minus 3x gives us 3x. And then bring down the plus 7. I guess I can kind of move this up so that we have some more space. Let me rewrite that. We have minus 5 equals 3x plus 7. Now we have to get the 7 over on the other side. We need to get rid of it from the right hand side. It's a positive 7, so again we're going to subtract to cancel that out. But whatever we do on one side of the equation, we must do to the other side of the equation to keep it balanced. So this cancels out our 7's over there. Negative 5 minus 7 gives us minus 12. And all we're left with on the right hand side is that 3x. And then from here, all we have to do is get our x by itself with one more step. When you have a coefficient, a number attached to your variable, like we have here, the 3 that's attached to our x, we can always cancel that out by dividing out the coefficient. We divide by the coefficient on both sides of the equation. So this means 3 times x. Well, we want to divide by 3 to cancel out that 3. Once again, whatever we do on the one side of an equation, we must do to the other side. So dividing by 3 will cancel these 3's out here, give us x by itself, which is our goal. We're trying to find out what is the value of x in this problem. And on the left-hand side, we just divide. Negative 12 divided by 3 is negative 4. The 3's canceled out. We're left with just an x on the right-hand side. That right there is your answer. X has to be negative 4. That's the one and only one answer that x could be to make this statement be true. We can check this by plugging negative 4 back into the original equation and seeing if you get the same value on the left-hand side that you get on the right. We can kind of do that quickly here. If you do 4 times a negative 4, you get negative 16, minus a negative 4 would actually be adding 4, would give you a negative 12 then, minus the 5 would give you a negative 17. On the right-hand side, you have 4 plus 6 times negative 4 would be negative 24. So that'd give you a negative 20 when you add there. And then negative 20 plus 3 would give you a negative 17 as well there. So we're getting a negative 17 on both sides if you were to work it out. If you don't believe me, you can work that one out more on your own. So move remaining like terms, move your like terms onto the same side, and then you combine them. Pretty much that's all you need to do to solve for your variable. And I think I'll cut this video, and in the next video we'll finish up the rest of the worksheet.